Hey, this is Todd Frazee, and this is the first in the series of 5 videos associated with the 5 deliverables for the transition problems uh, project. So during this project, we are going to be modeling all 5 of these transition ducts. And there are more than one way to approach this, but we're going to be using the loft command and a few other commands to create these. Um, We're going to start with A, B, then move on to C, D, and E. Each will have its own video, and you need to submit 5 separate DWG files on that particular project assignment in Canvas. Okay, so we're going to start with A, which is 2 circles, a square, base, and the project calls for the base to be like a solid piece, and it's shelled out to an 1/8 inch wall thickness. There aren't any dimensions, so you're going to have to use your judgment to try to be close to the proportions. But what we are looking for is that this transition geometry replicates what we see here. And the loft command can give you multiple results depending on how you approach it. So let's start with A. So we're going to go to AutoCAD. You're going to have an empty file, and you're going to be in the model space, and we're going to set this coordinate to world, and then we're going to start off in the top view. We're going to be working an inch in this one. I'm going to just guesstimate some numbers. You don't have to use the exact numbers I use, as long as you're relatively close. So I'm going to start off with a circle. Okay, and then I'm going to guesstimate that that's an 8-inch duct. So I'm going to put a 4-inch radius on it. Now the base is a square. You can use the rectangle command if you like. So I'm going to draw a line from corner to corner, and then I can use the move command to move that square and the line from its midpoint to the center of the circle to align them. Alright, so we have a square that represents the bottom. We have a circle that represents the diameter. Okay, so we're going to rotate to a 3D view, and now we're going to use the move command. We're going to turn ortho on, and we're going to do the move command. And we're going to move the rectangle. And we're going to move it from one of its corners straight down, and we're going to go 14 inches. Okay. Now, the loft command needs closed entities. So had I made this square out of individual lines, you need to use the join command to join those 4 independent line segments into one. Now we have a flange on the top. Now I'm going to show you 2 ways to do this part, and the first one is actually going to be technically somewhat wrong, and then we're going to come back and do it correctly. And the reason is I want to show you the difference between the lofts. Okay, so we're going to go ahead and create another circle that's going to be the transition for the flange. So it will represent the distance between where this curvature ends and where the duct splices into another duct. So we're going to do a copy command. You're going to select your circle. We're going to hit enter. We're going to pick the center of the circle, and we're going to go down 2 inches. Okay, so we've got those two circles. Now the simplest loft would be to connect these three sections. Now let's go to Solid, Loft, and we're going to select the square and our two circles. And the default is smoothing, so it's going to take and make a curve transition between, basically a 3-point arc between the three cross sections. So if you are doing lofting, you generally want to have actually more, if you can, have more than three sections, and you'll generate a more smooth spline and not assume that you want an arc. Okay, that's not what we want, but we're going to go ahead and accept this, and your mode should be in solid by default. If it's not, you have to type in MO here, but mine's at default. And then we're going to go to settings. Well, a dialog box will pop up. We're going to pick on settings, and instead of doing a smooth fit, we're going to do ruled. Okay, so that looks relatively close, and let's go ahead and hit OK. Now, the ruled took it from being a curvature to straight transitions between each section. So you could literally put a ruler between the two sections at any given point and have a straight line. That's what ruled means. Now I'm going to go to shaded mode, and we're going to add shaded with edges. And this is close. It's curved here, but we don't have a true flat here. If we are to look at our drawing, we pretty much have a triangular flat that terminates with radiuses on the corners. We're not going to be able to achieve that by doing a three station loft. What we're going to need to do is do a 2-station loft between these two and use what are called guide curves to force the shape to represent what we see here. Then we can come back and either extrude, or we could loft or push-pull the opposite ends to make up these transition flanges. Okay, so let's go back to AutoCAD. So this is not what we want, it's close. So what we're going to do is we're going to just hit back up until our solid disappears here. Okay, so we're back to our geometry. What we need to do is create some curves that we loft between the sections, but the guide curves control what's going on in between. And to achieve what we have in our drawing, we need to do some construction geometry. Okay, I have ortho on. We're going to go from the center of the arc out, and we're going to go again from the center of the arc in the opposite direction. We are then going to trim and delete, and then we will extend the lines to the limits. Okay, so what our goal was there was to create lines that we can pick on to create our guide curve. So if we're to look at our PDF again, we have a triangular section going from the corner up to the arc and back down, where this is a flat plane. We need to create a curve that represents each one of these edges of the flat triangle section. So you're going to connect the corners, we can turn ortho off now, to the quadrant lines we just drew. So you're going to end up with a series of triangles that make facets. So it should look something like this when you're done. And at that point we can come back and delete the quadrants that we made just to clean it up. Okay, so now we're going to go back to our loft command. go to solid, I go to loft, and this time I'm only going to pick 2 sections. So we've got our rectangles, our square, and our circle. And now we're going to accept that by hitting enter. And now we're going to select this guides. Select guides, and then we're going to select in order, going in a clockwise fashion. You don't want to do these out of order. We're going to select each one of these guide curves, and it's going to force the surface to stick to those wherever those land. We're going to hit enter, and we should have a solid. So let's go back to shaded view and see what we have. So we now have something that's closer to what represents letter A. We have a flat plane, we have a variable fillet that goes to 0, and it goes all the way around. All right, so the next step is we're going to add this extension on the top. And this time I'm going to use press pull. I haven't used that yet in this class for you guys, but it works pretty well. You can make holes with it and you can extend. It's a little bit faster than using the solid body. But you're going to select the top face, and it's going to allow us to push pull. And since we started with origin, we can just go ahead and select the origin, and it makes it the height of the distance we had there between the 2 circles. Now at this point we want to use a different solid command, and it's called shell. The assignment calls for this to be an 1/8 inch thick duct section, and the bottom needs to be solid. So we want to do the shell command prior to adding the base to this. Otherwise it will make a hollow where we don't want it in the base. So to do so, we go back to the solid tab and we pick on shell. It's going to ask you which solid to use, which is this one. If you can't select it, that means you've made a surface and not a solid. The next prompt is asking what faces do you want to remove. So we want to remove the top and the bottom. It'll be open, and the rest of the walls will have an 1/8 inch wall thickness. We hit enter to accept, and then we need to type in the wall thickness offset, 0.125, which is 1/8 of an inch, and hit enter. And it should create your solid. So here we go. We've got a wall thickness of 1/8 inch, and we have a duct that's relatively close to our drawing. And now we just need to add the bottom. Okay. So we want to add to the bottom on here. If we press pull on this edge, we're just going to get a thin edge, and we want a solid base because that's what the assignment is calling for. So to do so, I'm going to first switch to wireframe mode. The object snaps seem to work a little better, and we're going to do basically a square from one corner to the opposite extreme corner of the base, and that'll allow us to do press pull, and when we approach that boundary we can select the boundary, and we're going to press pull 2 inches. Now when we switch back to solid mode, shaded mode, we're going to have our 2 inch base here. Okay, this is a good time to save. Okay, so we need to take our solid is made up of 2 bodies, and we need to join those together. Okay, so now it's all one piece. Now the last part of the assignment is to slice it. We're going to use the slice command. We're going to tell it we're going to slice this entire body in 2 pieces. And the easiest thing to do, we're going to accept that. The easiest thing to do is to use 3 points, which is the default. So we just need to pick on 3 vertexes. So we're going to use 3 points, and we need to find a plane. between those 3 points. So we can go corner, let's put our filter on vertex, see if that helps us pick that up. Maybe not. Okay, so we're going to go from outside corner to the opposite outside corner. And then we can go up to the center of the top circle, and that should give us a plane. And it asks you if you want to keep both sides or not. Yes, we do. So we'll take the default. And we've now sliced the model in 2 pieces. Now we need to do a rotate command. And you need to make sure you're still on the top view when you do this. And we're going to select 1/2. And we're going to accept that half, and we're going to rotate about one of the back corners. And let's rotate it 120 degrees. And that should give us a good shot of our part. Now if you want, you can get rid of that square I had there and the extra circle. We don't need this. Okay, so should look something like this. It'll prove that you split it in half, that you've got the 1/8 inch in the middle, and that we have the correct faceting where you have the triangular flat broken up with the corner fillets. All right, that's it for this one. You're going to upload a DWG on the assignment, but you want a separate DWG file for the A, B, C, D, and E. A, B, C, D, and E should have all separate files, so probably call them transition piece A, another DWG for B, C, D, and E. And you can upload multiple files in Canvas, but to get the full credit, you need to have all 5 of those made. We're going to move on to the next one, which is B, so I'll catch you on the next video.